Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Binti Mohamad Jamil and I am from CS249, degree in mathematics. And in this video, I will be talking about surfaces and how to plot them. And also, I'll be showing how to plot surfaces and solid through Maple software. But before that, let's get into the introduction. Cylindrical and quadric surfaces are the other two types of surfaces other than the special surfaces which are planes and spheres. In order to sketch the graph, determining the curve traces or cross-sections of intersection of the surface with planes parallel to coordinates planes is very useful. There are a lot of different surfaces employed in 3D graph which are ellipsoid, cone, elliptic paraboloid, hyperboloid of one shade, hyperbolic paraboloid, and hyperboloid of two shade. Okay, for the first equation, which is x squared plus y squared plus z squared equals to 4, when comparing to the equation of ellipsoid, we know that the value of a, b, and c are equal. So when the value of a, b, c is the same, we know that it is a sphere with a radius of 2. So in order to sketch the graph of the surface, we need to come up with all of the traces, which is traced in xy plane, traced in yz plane, and traced in xz plane. After combining all of the traces, we can actually sketch the graph of the sphere. So this is the graph of the sphere. Okay, plotting the equation into Maple, we will start with the command of with plots. This restart command is just to clear up the values before this. And then we're going to run the command with plots, and then I use the command implicit plot 3D, insert the equation, and we need to determine the range of the axis. So I choose -3 to 3 because I know that my the radius for my sphere is 2. So I can also choose 2, but I cannot use -1 to 1 because the sphere will not gonna fit. For question number 2, x squared plus y squared equals to 4. So we know that the value of z is 0. So z is said to be free. So it is a cylinder. So since z is free, we can just trace it in xy plane. So it becomes like this. And this is the sketch of the graph of the cylinder. So plotting the equation into Maple, we use the command with plots and then we run it. And then I use the command implicit plot 3D, put the equation, and then set the range for x, y, and z axis. So I choose -3 to 3 because the radius of the cylinder is 2. So question number 1 asks us to plot the solid that lies between the cone. So this is the equation of the cone and the plane z equals to 4. So by referring to this table, we know that the value of phi is pi over 4 for a cone. So we can find the value of rho, which is 4 second pi over 4. So this value of rho and phi will be used in the Maple command later. So the equation is z equals to x squared plus y squared. So we will transform it into this equation and then we will find all the traces in xy plane, in xz plane and yz plane. And then we will combine all of the traces to sketch the graph of the cone. So this is the graph of the cone since the plane z equals to 4. Plotting the equation into Maple, we first let fx equals to x squared plus y squared and then we run it, and then this is the equation of the plane which is z equals to 4 and then we run it, and then now plot the graph of the surface. So this is the graph of the surface, and then we use the commands of cones equals to plot 3D, rho theta pi over 4. The range of rho is from 0 to 4 second pi over 4. This is the value after calculating the value of rho previously, and then theta equals to -pi to pi and coordinates equals to spherical, and then we run this command, we will get this. And then using the command with plots, and then we run it, and then we use the equation, we use the command of plane equals to plot 3D, 4 second phi, theta is from -pi to pi, and then phi is from 0 to pi over 4, and the coordinates is equals to spherical, and then we run it, and this is the plane z equals to 4. And then lastly, we use the command of plots display, cones, plane, viewpoint equals to circle left, and then we get this solid. So question number 2 asks us to plot the solid that is inside the hemisphere. So this is the equation of hemisphere. Outside the cylinder, so this is the equation of cylinder. So we first plot the cylinder. The cylinder is with the radius of 2. So, looking at the equation of hemisphere, we know that it is a hemisphere since it has cert. So, if we transform the equation into this, it's going to be a sphere. So, let's trace the xy plane, yz plane and xz plane for sphere first. So, looking at all of the traces, if we want to take the hemisphere, we will ignore the bottom part because the hemisphere has cert. So, we will take only more than or equal to 0. So, after combining all of the traces, so this is the sketch of the graph of the hemisphere and cylinder. So, plotting the equation into the mapper. So, we use the command of fx equals to cert 25 minus x squared minus y squared. So, and then the next command is the equation of the cylinder, and then we plot the hemisphere. So, this is the graph for the hemisphere. And then we use the command of hemisphere equals to plot 3D, cert 25 minus x squared minus y squared with the range of -3 to 3. And for y-axis is also -3 to 3. So we will get this. And then we use the command of width plots, and then we run it. And then we use the command of cylinder implicit plot 3D. We insert the equation of cylinder with the range of -3 to 3. Same goes to the y-axis. And for this z-axis, we use -5 to 5 according to the radius of the hemisphere. So we will get this as the result. And then we use the command of display hemisphere cylinder scaling equals to constraint. So we will get this solid. Ellipsoid and spheres can be differ in the value of a, b and c in the same equation, where if the value of a, b and c is not equal, then it is an ellipsoid. So for the case of question number 1 in section A, it is a sphere as the value of a, b and c are the same. A circular cylinder can be determined by looking at the variables. If one of the variables is missing from the equation, then it is a cylinder. For example, in question number 2, section 1, the variable z is missing from the equation. So, z is free, thus it is a cylinder. So, solid in section B can be sketched by looking at all the traces in every plane.